So, hello again. This is Travis Schneider with RE Squared Robotics, and in today's episode, we're going to talk about the nuts and bolts associated with robotic arms. That is, we're going to talk about the hardware components that make up a robotic arm. So, joining me today is RE Squared's Director of Hardware Engineering, Allen Bancroft. So, thanks, Allen, for joining me.
Oh, no, this is great, Travis. Looking forward to it.
That's great. So maybe just to get started here, Allen, could you give us a little bit of background about yourself?
Sure. So I've got my electrical engineering degree from DeVry University and also received my MBA from the University of Notre Dame. Also received my Six Sigma black belt from Virginia Commonwealth University, or VCU as they call it. Been involved in robotics for over 32 years and learning stuff every day. I like, maybe on a personal side, I have a wife and two wonderful children, some of which they've all been involved with robotics as well. And then I enjoy racing cars and automotive sports in general. I prefer driving when able, but also private pilot, enjoy flying as time allows, and like being outdoors. Yeah, that's a little bit about me.
Wow, so 32 years in robotics. So what initially got you interested in robotics?
Probably when I was about 8 years old, if I remember back correctly. I remember seeing the M3-B8 Gunter robot on the TV show Lost in Space, which of course now they just call that robot B8. And I just thought, man, that was the most inspiring thing. I never actually saw a moving machine as a youngster, and I thought, man, that is really something. And I was really intrigued on how it moved and how it worked around. Of course, maybe as a lot of others in the world, I made a nice cardboard mock-up of a robot and then realized after I made it, it actually didn't move. So it wasn't as exciting as the one I saw in Lost in Space. But I think just at a young age, I was just really inspired by the mechanical and the movements of that unit.
That's awesome. So you talked a little bit about, I guess, I'll call it your hardware inspiration for robotic systems. One other question I've been asking a lot of the other participants in these episodes is who inspires you? Do you have any personal inspiration that you look toward?
Yeah, I would say, leaders as a general concept inspire me. People that are really thinking out of the box, doing things that are maybe under, calculated risks, doing things that others haven't done before. Maybe if I turned it a little bit more into a personal inspiration, I was very inspired by Joseph Engelberger, who even to this day is considered the father of robotics. I was fortunate enough to, right out of school, right out of college, work for him under his guided leadership for several years, and got to know him on a personal level, and just very, very inspiring, very brilliant person. But there's probably dozens and dozens of leaders that over the years I've gotten the opportunity to either work with or get to know or learn from. So yeah, I think just in general, I'm inspired by just generally leaders.
Oh, that's definitely a fun fact for the day that I learned about Allen. I didn't realize you had a personal connection there.
Yeah.
So maybe for this next section, we'll start to talk a little bit more about the hardware specific topics, and maybe just starting at a high level. Allen, could you describe for people maybe whom aren't as intimately aware of or familiar with robots, some of the major hardware elements associated with a robot and its construction?
Okay. So motors are pretty standard in robotic systems. There's all different types of motors, all different size types of motors. I would say gearboxes or gear trains, as we may call them, sensing systems, grippers, or the actual hands, or the types of things that might be used to move items around. Certainly we have structural elements that would tie all those components together. It could be made out of castings, maybe aluminum materials, maybe carbon fiber, magnesium in some of the more sophisticated units, steel and other such materials like that are really used to just take all these components and put them in a housing and in a form factor that's usable to the customer.
Okay,
and then
that's great.
On top of that, we've got electronics and control systems and software, and I would say those are probably the high level components.
Got it. Okay, cool. And maybe another question that I sometimes get from customers when talking about applications is, so we as RE Squared, we make a wide range of robotic systems with a wide range of degrees of freedom. Um, what do you think is most common in terms of the degrees of freedom associated with a robot? And can you explain for a little bit for people who aren't as familiar with robots why that might be?
Yeah, sure. So we have 7 degrees of freedom in each of our arms. So there are companies, and we have as well, made 7 degree of freedom arms. Typically, those might need applications may need that many degrees of freedom, especially if we're doing, which RE Squared focuses on, is human-like manipulation. Um, I would say, from my perspective in industry, you typically see not as many 7 degree of freedom arms. There's a lot of 6 degree of freedom arms out there. So there's usually a degree of freedom that isn't necessarily always needed in some applications. There's also robotic arms that have as low as 1 or 2, 3 degrees of freedom arms. So it really depends on what the application is, to maybe make the robotic arms less sophisticated. But I would say, yeah, probably 6 degree of freedom arms are probably the more standard, especially if you're looking at the industrial robotic industry in general.
Got it. Okay. And then maybe one other like application related question too. And again, this is kind of geared toward those people who might be interested in robotics but not really know where to start. Um, are there some common application topic areas or things to think about, things to document for people that want to get started but just don't know where to really get started? Again, robotics can be oftentimes intimidating, but I think there's probably a couple of things that we could probably break it down to try and make things a bit more straightforward.
Yeah, sure. No, great question. I think as a customer, some things that they should be thinking about is what is it maybe that they want to lift, or what is it that they want to move? How fast maybe are they interested in having these objects be moved? How many they may not necessarily know how many degrees of freedom. Typically, we may have that conversation with them. Well, based on moving this, we probably need X amount of degrees of freedom. Some customers have done some research online and maybe said, hey, I think this 7 degree of freedom type application is perfect for me. It's more human-like. Or they might say, look, I just need to pick something up and move it. Maybe a 2 degree of freedom might be something we can consider. So, but typically we'll help them sort of dial into that. Maybe they would need to share with us what kind of power capacity that they're thinking about. Hey, I'm thinking about putting something in my plant, and I only have this much power. Maybe I don't have enough power to run a big industrial arm, but maybe I have lots of capacity to run things that are battery powered, which of course we focus a lot on. They may want to share with us, or they may want to be aware of what kind of noise concerns would they have as they're having communication with us. Hey, I'm going to be using this robotic arm in this type of an environment. So that may need to be quiet. Or, hey, look, we're going to be using this robotic arm outdoors, and it's in a very noisy environment, so that's maybe not as important to me. And those are things that would help, help us for sure, and help other robotics companies sort of help dial in on what that, what that robotic solution might look like. We may have to have a conversation about weather conditions. If we are going to be outside, is this going to be a really hot environment? Is this going to be something that may be exposed to rain or other bad weather conditions? We'll have conversations about sensors. Hey, look, I'm really concerned about this robot potentially, hitting this item. So we want to have a conversation with customers about, the perception and the safety sensors that may be included with that. You may go as far as, hey, there may be applications, and this is more in the industrial world where they might want to put a cager on a robotic system to make sure humans are not in there. That's not necessarily where we operate. I mean, we're operating in more controlled atmospheres where we're not necessarily worried about people, coming into our workspace. But, you need to be sensitive to, what the safety requirements might be and need to be.
Gotcha. And actually, some of your responses related to environmental concerns kind of actually feed into my next question for you. So RE Squared as a company, we try to focus in on a lot of mobile manipulation applications. So I guess when I say mobile manipulation, what does that mean to you?
So to me, maybe I'll start at the other end. There's a lot of companies that industrial robotic companies, and they make solutions that bolt to the factory floor. That robot's not going to move. That's not really who we are. I mean, our mobile manipulation is we're taking robotic manipulators. We may put them on mobile platforms, to have them move around. But in general, it's where I think of industrial applications, products are being brought to that workstation, and that robot cell is doing something. The way I view RE squared is we are going to the point where we need to interact with the task. So we go and we do a task, and then we may move and go to another place to do a task. But we're very much more autonomy driven and more, not necessarily bolted to the floor, just waiting to stuff, for stuff to come to us. We are actually going to interact with the task directly.
Huh. That's an interesting perspective. So instead of, the infrastructure being set up to integrate to a robot, really what we're trying to do is adapt to the existing infrastructure and not have to change it up on the part of our customers. I hadn't thought about it that way, but that's a really interesting way of thinking about it.
Yeah, and from the customer perspective, it's probably much more cost effective to them. Oh, you mean I don't need to change my environment and you can just come and do the task? Oh, thumbs up. I like that. So yeah, good summary for sure.
That's great. Cool. And just some other topics or some other questions here too for you, Alan. So you've obviously been in the robotics field for a long time, and RE Squared's had the good fortune of hiring a lot of young engineers recently. But for those who might be interested in a career in robotics, what advice would you have for them? Like, what sort of activities do you think they should get involved in? Are there things that they should be doing to kind of build up their resume? What are your thoughts there?
I would say, for a crowd that, is maybe still in college, not quite sure, and maybe even I'll start in high school. Generally, there's a lot of programs maybe in your high school or in other surrounding areas where you can get involved with STEM activities, science, technology, engineering, and math activities. Some schools, probably more so now over the years, have gotten robotic programs in their curriculum. I would say, plug yourself in there. You'll start to learn things at a very young age. I would say as you start, if you feel that, engineering is robotics or engineering in general is a field that you'd be interested in, I would suggest the same things as you get into college. Get involved with robotics programs or get involved with any of the STEM related activities, because you're going to learn something. Either it's maybe some hardware or mechanical design or electrical, or you'll learn software. And as you get through your college curriculum, you may start to realize that, look, I really enjoy writing software. I like designing printed circuit boards. You may realize that, hey, look, I worked on cars when I was younger, and now I'm more interested in the design of the mechanical structure. And then, as I would say, as you start to transition and looking for that first career path, is do your research. Look at robotics companies around the globe. Certainly, Pittsburgh has, I believe, it's 62 robotics companies. I mean, there's a lot of technology going on, even in right where we are, and just share your passion about robotics with, as you're interviewing folks. We've hired a lot of folks out of STEM programs, as you pointed out. And we've hired a lot of people that just, quite frankly, have the passion to do robotics, even though they may not necessarily recognize if they want to do a certain discipline. So one of the things I encourage people is, look, try and get your foot in the door. And getting your foot in the door with a robotics company might be that, look, I went to college, I'm a mechanical engineer, and that's my degree, but I've also have a passion for software. And try and, set that stage early that, look, I want to learn lots of different things. Robotics, affords that opportunity, right? There's so many different aspects of making a robotic arm go on a mobile platform and do very sophisticated tasks, that there's a lot of opportunity to, grow and navigate into different areas. But I think getting your foot in the door with just the passion and the interest you have in robotics is certainly a way to start.
Awesome. Well, that's some great advice. I guess, Alan, in closing, was there anything else that you wanted to cover today, or any other topics that you wanted to bring up? Yeah,
I mean, maybe nothing's very specific, but I look back on a career of 32 years, and I hope I have at least another 32 years to go. The field of mobile robotics is constantly evolving. I think back of the days, even working with Joe Engelberger, and, you'd laugh if I told you the type of really sophisticated things we were working on back then, which now, sits on my cell phone, right? And here we are, 32 years later. Who knows what the technology is going to look like 2 years, 5 years, 10 years from now, and the type of development and engineering that's going to be required to, take these systems to the next level. So just, it's a great and growing and thriving industry. You're starting to see robotics in general expanding around the world. And, and once again, as an engineer, whatever your discipline is, there's probably, a nugget of your experience in robotics that could be used, right, to help these systems get to the next level. So, no, I'm fortunate and thankful for the opportunities I've had to be involved with robotics. 32 years ago, did I think I would 32 years later still be involved with robotics? I don't see any other career I'd want to be in.
That's great. Well, I didn't have anything else for you today, Alan, but thank you for your time, and thanks for sharing your words of wisdom today.
Yeah, Travis, thank you for letting me be a part of this. This is exciting, and I hope I've inspired someone else that will be seeing this broadcast to get get involved with the field of mobile robotics.
Oh, great. Thanks, Alan.
Thank you.
Since 2001, RE² Robotics has remained committed to our mission to develop innovative technologies that make a positive impact on the world. RE² is a leader in the design, development, and manufacture of human-like robotic technology, solving the most challenging applications in the world. If you would like to be contacted about a robotics application, please email us at myrobots@re².com. That's myrobots@re².com. To stay up to date with the latest RE² news, visit our website at www.re².com, or you can always follow us on LinkedIn, Instagram, Facebook, and Twitter. If you'd like to see more videos like this, or videos featuring actual RE² robots, please subscribe to this channel on YouTube.